Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about confidential computing and the DevOps lifecycle with special guest, Director of Product Management from Anjuna Ophir. Ophir, welcome to the show.
Hi, Darren. I'm so happy to be here with you.
Now, I was going to say your last name, but you said don't even give it a shot, Darren. So, Ophir, tell us your whole name. Give us a little bit of background about yourself.
Right. So my last name is Azulay Rosanes, and it's a combination of my wife's last name and mine. You know, we are progressive in one way or another. Go figure what will happen with our children. I've been with Anjuna for a little bit more than a year, and I'm really happy to be a part of this amazing secure enclaves technology that is really a game changer for the whole security industry. And I'll be happy to talk about that today.
Yeah, in fact, I was actually really impressed with Anjuna because you guys, obviously, you're going to leverage Intel's technology. If you weren't, I wouldn't have you on the show. No, I might. I don't know. But you guys do leverage some of our technology in addition to other technologies as well. So you guys put a nice abstraction layer around confidential computing, which I really appreciate because that lets me do lots of different things that normally I probably wouldn't be able to do.
Exactly. This is where we find the secure enclaves or the confidential computing technology as something that really changes the world. So far, there was no solution for data in use, for protecting the data in use. And this hardware-based technology that comes from Intel in the case of SGX is really enabling to solve that last problem of running your software anywhere and not being concerned about someone getting to the machine and just dumping the memory, as we'll talk about later on. And at Anjuna, our mission is to make the use of the secure enclaves the simplest as possible. No need to change anything in your application, just take it and run it in an enclave. We'll make the SGX technology work out of the box for you.
I love that. And when I heard your story around that, I said, hey, wait, I've got a problem over here, a big, huge problem. And it's the attacks on the secure supply chain, software supply chain. We know the SolarWinds attack was an attack on DevOps, and no one's really locked that down. We had some ideas on how to do it, and with your technology, you kind of just made that really easy for us to do.
Agreed. This is really the way that we are enabling the secure enclave technology makes it that you don't need to re-architect your application, your software. You use the same methodologies like before, but now you can simply run them in secure enclaves and have the protection that secure enclaves provide. And we'll talk about that. The memory protection and the encryption of the memory and the ability to identify the software in a hardware-based way through the remote attestation that lets you run your software and nothing else could run the same software and access the same secrets.
Well, and that's what I liked about it, because when I look at, people don't understand, I'm a DevOps guy. Before it was called DevOps, I was a ClearCase admin for all you old people like me. That's where I cut my teeth. I wrote a couple books about ClearCase administration and philosophy and strategy. So when I hear all this DevOps stuff, I said, yeah, we know this stuff. This is all, but securing it is very complex because there's several different applications running and there's interaction between applications and there's scripts running and all this. So we started looking at how can we use Anjuna and SGX enclaves to really secure our dev environments, our build environments, our test environments, and of course, deployment. But there's also this weird thing that happens towards the end of a DevOps pipeline. It's the release cycle. And that's where SolarWinds got smashed, right? I mean, code was injected in. It wasn't even code. It was a library. It was injected in at the last step. So we said, we really need to lock down all those environments independent of each other. And with your guys' stuff, because you make it so easy to do, it just made it a simple additional step, I guess would be the right word.
Exactly. You can look again at your software lifecycle when you build it and take all of the different components and identify the places where you need to protect the running process from any such hijack. And with our software, you simply identify that component, that application, will show it with HashiCorp Vault, and you just run it in an enclave. Of course, that you may want to think about which secrets you want to provide to that enclave, and we'll talk about that as well, using the attestation quote ability of the SGX enclave to make it that only that specific software component will get access to the secrets.
All right, so let's talk about this a little bit. I named it the hardened DevSecOps pipeline, but it's a bunch of moving parts.
Mm-hmm.
And we decided, hey, let's try out one or two of the moving parts first, make sure it can all work. But the stack kind of fits like Intel SGX on the bottom because we're Intel, right? Using Red Hat OpenShift, very well known. We don't want to recreate DevOps pipelines. No, that's no fun. Using Anjuna for the confidential computing part. And then we looked at, all right, what's one of the major components that we want? HashiCorp's Vault was one of those main components to store what we call a secure ledger or a secure SBOM through the process. So that's kind of what we said. All right, let's give this a shot and see how long it'll take. I was shocked at how fast we were able to just boom, and it was done. I attribute that to you guys. You guys did a great job.
Yeah, I'll give it all to our engineering and our CTO that came with the amazing solution that we'll talk about. I want to just talk about the terminology that you're using, the hardened DevSecOps. I think that there couldn't be any better terminology because DevSecOps is already taken.
I know.
It's a new DevOps. So we need to harden that. And this is exactly what we
didn't want to call it SecDevSecOps.
Yeah, exactly.
Or DevSec squared ops.
No. Not
allowed
here.
It is different too, because we're actually securing the DevOps pipeline or the DevSecOps pipeline, because you still need to put security controls in your DevOps as well, meaning, hey, correct. I'm going to check my binaries to see if they've changed or not. Or I need to run, there's a company I talked to just the other day where they're actually analyzing binaries to see if they match any known patterns. This is fascinating, right? Any known patterns of malware, which is cool, right? That's the sec part. The hardened stuff is what we're doing. We're hardening up that DevOps pipeline. So that's why I called it that.
And it totally connects because the hardened comes with the hardware technology, the SGX technology. So you take the DevSecOps, put SGX, and it's hardened with Anjuna.
Yeah, with Anjuna, that's right. That's right. All right, very cool. So, hey, let's dig into a little bit more on, let's dig in a little bit more on confidential computing in general, right? Where's this coming from? Because it's not just SGX. Correct. There's a whole consortium around this, right?
Correct. So for those, if there are people that are watching or listening that do not know what secure enclaves are or confidential computing in their other name, it is coming to solve the problem of protecting data in use, meaning that the solution for data at rest, when you store data to a persistent storage, is already there. You can encrypt data in files, and so if a malicious insider or whoever has access to those files, if he does not have the decryption key, he cannot do anything with that. So that's solved in a way. Also, we have a solution for data in transit. Data over the network, everyone uses today TLS. You cannot just listen to the wire and understand what's there unless you have the right key to decrypt the encrypted traffic. So again, solved. But the problem that was not solved ever since is when the data is in use. When the application needs to access it in the memory, it needs that in the clear. And so the data cannot be both encrypted and used at the same time. And this is an endless loop of a problem. And there is no software-based solution that can solve that problem, so that at the end of the day, if someone has access to the machine in which the application is running, It is as simple as coming to the machine, identifying the process, and just creating a memory dump. Boom, you don't need to be a security expert. You'll get all of the secrets, all of the confidential data on the file that you can take everywhere, and it's not encrypted. It also will include the keys that are being used to encryption at rest and in traffic, because the software needs to use them in order to encrypt. So you have really all of the secrets that you need to have.
So if I gain root access on a box, which that does happen, right? I mean, people hack in. What you're telling me is I can now do a memory dump on any application in there.
Any application.
And, especially if it says the application's name is encrypt this. That's my most favorite application I wrote, right? Then all the keys are stored. So they basically have the keys to the kingdom. They can go wherever they want.
Exactly. And now someone will tell us, listen, I trust the people that manage my server. So that's, first of all, a question. Okay. I'm not sure. But even if you trust them, we have on a daily basis 0-day vulnerabilities. Right. The world identifies the log4j. And with the log4j, sometimes you can get into the machine through a vulnerability. Now, once you go to the machine, you can start moving from one application to another, start jumping from one server to another, and get the keys to all of the kingdom. If you run the different applications in secure enclaves, this problem is being resolved, because maybe you got access to the machine, but you cannot have the access to the memory of each and every application. It doesn't mean that you don't need to resolve the vulnerabilities, but you're much less stressed to resolve them as soon as possible. Even if there are kernel vulnerabilities, when something runs in a secure enclave, the kernel cannot access its memory, a super user cannot access its memory, any other privileged application on that machine cannot access its memory.
Okay, so this is for really highly confidential type, right? Like storing keys. Great example why we would want this in Vault.
Exactly.
Right. I'm storing keys in Vault. I'm storing secure information. So is there, if I'm running in an SGX enclave or any of the other confidential computing enclaves, because there's other technology out there as well. What kind of performance hit am I taking in this? Is it pretty dramatic? Are we talking 2 times slower, or is it like 5% slower? Or because there's got to be some kind of hit.
Right. So first of all, the usual answer is that it depends. But let's start from the fact that all of these technologies are hardware-based technologies. Yes, if you had to run encryption in software, your penalty would be that high. When you're running it on the hardware level, and you guys, your engineers, are doing magnificent work of reducing that effect to the minimum, and the latest chipset that is available now in the market is Ice Lake. It is totally a game changer, and the performance hit is very small, up to negligible. It also depends sometimes on the applications, but this is where at Anjuna we have the knowledge of how to fine-tune the configuration of Anjuna to run your application and gain the performance that you need.
So a little bit of overhead, maybe 20-30%, or
much less.
Oh, much less, like 5
in the single-digit numbers.
Oh, that's not too bad, because so what that tells me is you may not want to put everything in a secure enclave, right? But
maybe not at the moment, but this is the future.
But you think it's the future? Okay.
Totally.
Very cool stuff. So let's take a look then a little bit at, all right, using this technology, right? Things at rest. We came up with some ideas on where I could put a secure enclave, things that I want to protect. So one of the things that we looked at was, hey, I want to protect that secure ledger, because the secure ledger has in there everything that went into the build with its hashes, so that I can check those later, right? I don't want those changed throughout the cycle, because then someone can inject code or libraries or binaries into my package that I'm delivering out to the world, or into my everything has to be in a container now, right? We're in the modern world now. Everything runs in a container. So that's a good candidate. What other candidates do you think would be good for protecting in the DevOps pipeline?
So for example, usually you'll want to sign your software at the end of the process of building it.
Yeah.
And signing your software means that you need access to a private key that only you have in order to sign the software. Today, without secure enclaves, what it means is that after you have that binary ready, you need to take it to another machine in a very dark room that no one has access to, but 3 people with 3 different keys, and sign it there. What the secure enclaves enable is to provide access to that signing key in your standard environment, but only the enclave will have access to that signing key. Nothing else will have it, and it will be based on the hard identity of the software running inside the SGX enclave, which is implemented via the attestation quote. What it means is that we can provide, and we can talk about that later more, access to secrets in HashiCorp or Vault only if the request comes from a secure enclave, and only if that secure enclave is exactly the one that we intended to run. It has the software measurement that identifies the software in a unique way, so that if you change 1 bit, it's already a different software that we don't trust.
Oh, this is cool. So I can attest enclave to enclave is what you basically explained.
Totally.
Right? Did I get that right?
Yeah, and also you can attest enclaves to stuff that runs outside of enclaves. It gives you totally the ability to trust software that runs somewhere else, and to be sure that this is the software that you trust and nothing else.
That is pretty cool. I didn't even think about certificate signing. That's a good one. One I was thinking about is compilation. One of the big, huge problems I know in Department of Defense is they want to be guaranteed that everything that went into my build, I can trace back to the developer that wrote it. And this is for primarily embedded systems, right? When you've got software that's controlling, multi-million-dollar machines that can kill people or save people's lives, you don't want anything messing in there, right? You want full traceability. So I thought, hey, doing my builds in a secure enclave might be a good idea.
And we can also take it to the software that runs on the edge. Even the software that runs on the edge, sometimes you want to protect the software itself. This is your IP. If you're using SGX, you can make sure that only the software, when it's running in the enclave, will be unzipped, unencrypted, and run. And we have customers that have their equipment going to different places, and they know that their competitors or something else can get access to those machines. And with the secure enclaves, even if I get access to that machine, I cannot take not the code or the data, even though I have that machine on my premises. I took it to my lab or something like that.
That's very, very, very cool stuff. Okay, so let's talk about, let's talk about attacks that we talked a little bit about attacks. I know there's different levels of, enclave. I can do an enclave for a really large set of programs, right? Because I can just do an enclave for a kernel. I could, right? Or, a shell, and then run whatever I wanted in there. That doesn't really do much for me, right? So what attacks does this really solve? You talked about the one about the memory dump. What other ones can it help solve?
So if we'll talk about the Intel SGX technology, the level of the enclave is at the process level. So as we've talked before, an attack on the kernel does not affect what's running in the enclave. And of course, that what we're doing at Anjuna is that we are making sure that in cases that you need to go to the kernel, we'll protect whatever needs to be protected in that interaction between the enclave and the outside world. So that's one. We've talked about the ability to protect against accessing your code. We've talked about the ability to make secrets available only to the enclave. So you mentioned a server. A server needs a TLS certificate. Usually that TLS certificate needs to reside somewhere on the machine. But if it resides
I just put it in /root. Isn't that
exactly? But if you come to /root on that machine, you'll figure out what's that certificate.
It's stored under the .keys directory, right?
Exactly. And there it's in the clear. So
yeah, exactly.
That problem, it's a problem. And you may say, you know what? I'm encrypting that TLS key with some other secret. But at the end of the day, one of these secrets must be on the disk, on the machine that runs that application. With secure enclaves, we can encrypt the data that only that instance of SGX, or with a solution like our policy manager, which is a key management system that is attestation aware, you can have the secrets available to the software, but to nothing else. And if someone comes to the machine, he won't be able to find not this TLS certificate in the clear, or the key that used to encrypt that TLS certificate, or the other key that used to encrypt that key that encrypts the TLS certificate.
Okay, so this is really cool. You guys provide more than just a way of you utilizing SGX easily, because there's other modes of SGX where I can embed it in my code and have parts of my app, and it's a rewrite, which that might be good for some applications, not for my DevOps pipeline. But you guys also manage key management as well, right? Now, can I run your ecosystem just on-prem, or are there cloud offerings as well that I can utilize with your guys' stuff?
So our world started with the introduction of secure enclaves or confidential computing to the clouds. Every cloud service provider today has an offering with secure enclaves. We support all of them. We support also the technologies on-prem, because it's, at the end of the day, it's the same technology. What I'll add is something additional that our software can do, which is on top of the basic offering. We can also enable the ability to encrypt your data at rest and in transit without you needing to do that in your software. We sometimes face applications, let's say,
they're legacy applications, right?
Legacy applications, or even new applications that decided that they don't have a support for encrypting each and every data file. With a simple change of a knob in our configuration, you can say this file will be encrypted by the enclave. And same goes for TLS termination.
Oh, very interesting. Yeah, because I'm an app developer and DevOps. So the old time DevOps guys, we did a lot of development too, right? So, and I still develop for fun. And I always have data. What am I going to do with this data? I got to put it somewhere. So what you're saying is I can be lazy. I can say, I really don't care about encryption. And instead, I just run that in an enclave and click the box, and it will encrypt my data files that I have there, all that.
Exactly, because the way that we look at the world, your data is your most important piece of
it's your most valuable asset.
It's your most valuable asset. And we know that, and we provide with Secure Enclave the ability to protect it at rest, in transit, and in use, using the technology of the Secure Enclaves.
No, I like that. All right, so a tough question for you.
Sure.
How, with the move to more micro segmentation and more micro architectures, right? We're talking containers. How do you guys, can you give me an extra level of support on containers, for example, because this is something I want. I want to build my container and have it encrypted, everything inside encrypted, and then use it like I'd use any other Docker container in Kubernetes, whatever. And then it says, hey, oh, this one's encrypted, run it in an Anjuna Anjuna enclave.
Anjuna Secure Enclave, we'll call it.
So, I mean, what's the steps in doing that? How do I do this easily?
So it is as simple. You deploy some pieces of software on your Kubernetes cluster. And then the only thing that you need to do in order to say, I want to run this container inside an enclave with Anjuna, is to take the pod YAML of that specific pod and add one small annotation, run in an Anjuna Secure Enclave. We'll do all of the rest. In a very
so you do it at the pod level. I like that.
Exactly. Yeah.
I like that. Okay, so integration with Kubernetes, very nice. What about just pure Docker?
So for a Docker, it's the same in a way. You can put an annotation, and that we can make that Docker run in an enclave without many changes.
So this gives me the security I need for small, because I'm thinking maybe I have an edge device that's out there, and this is probably the scariest part, right? I've got an edge device that's sitting out in the real world, outside of the confines of my data center where I've got security guards and all that. It's sitting out there in the real world, and I'm running containers on there. I'm running things on there. I want to make sure that puppy's locked down tighter than the stuff in my data center. And with this, I'm guessing the overhead with Anjuna, there is no server.
Exactly. This is one of the things that
So I can run disconnected. I can run all those things.
Totally. We don't need any centralized management. It all lies in the YAML configuration. And today's world with configuration as code and infrastructure as code, it is that simple to deploy Anjuna and to use it to run your application. Totally.
Oh, this is awesome. There's no call home.
No.
Right. I mean, obviously, I've got to do some license.
Yeah, stuff. But the license gets to the edge.
The license is attached at the edge. Gotcha.
Yeah, exactly.
Now, this is really cool stuff.
I agree. It's amazing. It's amazing. The technology is amazing. Let's put it that way.
Yeah.
We are an enabler.
Now, and you guys have abstracted some of this away because you work with more than just SGX, Intel's SGX. And Intel has other memory technology, confidential memory, like TDX is coming out in the future. So you guys will be able to support that.
Exactly. We guys are the humble partner of Intel, and we're working closely together so that when TDX would be available to customers, they will already have Anjuna's solution for TDX.
So no code change for me.
Exactly. Totally.
That is nice. I like how it's bolted. Under the covers, very nice. Ophir, this has been great to have you on the show today. You've opened my eyes up even more, and we worked on some of this stuff together already. If people want to find out more, what can they do to find out more?
Simply go to anjuna.io and contact us if you want to start a trial. If you want to have an interaction with us, we'll be happy to open you to the world of secure enclaves. And it's really an amazing world, and it opens so many opportunities. Some stuff that we didn't even have the time to talk about today, like multi-party compute in the easiest way that you could imagine. Really, this technology will change the security world.
Yeah, we've actually talked about that on the show before.
Okay.
Distributed, we call it distributed confidential analytics on the same machine.
Exactly.
Yeah, very, very cool stuff. Which, the possibilities are huge. Ophir, we'll most definitely have you back on the show to talk about other use cases. This has been wonderful. If you do want, we've written a white paper. Our names are on it. If I remember right, we're both on there. We wrote a white paper about the solution. You can check that out at embracingdigital.org and check it out on this episode. It's right there. It's totally available to everyone. Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.